Hi there. Want to learn a little bit about Paris and the Eiffel Tower? Well, you're listening to the wrong video. What we're actually going to learn about today is scientific notation. And you may have heard of it, you may have not. But here's an example just to get us started. It says astronomers often work with very large numbers. So if you think about it, well, we'll keep going, such as masses of planets or distance actually to planets. The mass of each planet in our solar system is given in the table to the right. Notice that each value is written as the product of a number and a power of 10. These values are called scientific notation. So you might see something like this when you're dealing with science. A lot of times they use scientific notation with really big or really small numbers. So like the mass of mercury in kilograms is 3.30 times 10 to the 23rd power. So with scientific notation, we're going to use powers of 10. So 10 to the 23rd power is just um, a 1 and then 23 zeros essentially. Um, so that's what we're going to deal with today. I'm going to try and make this smaller. Oh, well, nope. There we go. So our goal is to express numbers in scientific notation and standard form. So we're going to go from normal number, that's standard form, to scientific notation and backwards. So let's start off with what scientific notation is. Um, it's maybe worthwhile to write this down, maybe not, but in words, a number is expressed in scientific notation when it is written as a product of a factor and a power of 10, meaning a number and a power of 10. The factor, that number must be greater than or equal to 1 and less than 10. So anywhere from 1 to 10, um, but not 10, just less than 10. It could be equal to 1 though. So then in symbols, a number in scientific notation is written like this. A, so that's a number, times 10 to the n power, whatever the n would be. All right? And remember, a has to be between 1 and 10, and n is an integer. Okay? So, just as a review, 10 to the fourth power, what does that mean? Well, really, it means 10 times 10 times 10 times 10, or that would be 1, 2, 3, 4, 0, 10,000. We're not going to write, when there's a number that would be having that many zeros, you don't need to write it all out, because a lot of times we're going to have like 10 to the 50th power when we're actually dealing with scientific numbers, and we don't want to write all those digits. So we're going to use scientific notation. 10 to the negative fourth power, just as a review, would be 1 over 10 to the fourth power, or 1 over 10,000. All right? So going on from there, let's take these two numbers. Now, this is the first number, 6.59 times 10 to the fourth power. We're doing that because that's scientific notation. And what that means is it's really 6.59 times 10,000, or you can take that decimal and move it over 4 times, and you get 65,900. That's actually what the number would be. If you take this in your calculator and get it out, you get 65,900. And you may notice that the decimal place just moved 4 to the right. We'll notice that if it is a positive decimal on the power of 10, then it'll move it that many to the right. The second example deals with a negative exponent. So it's 4.81 times 10 to the negative 6 power. That means it's going to be a really small decimal. In other words, that would be 4.81 times 1 over 10 to the 6th, or times 0.000001, which you get the decimal right here. This is what that decimal would be, 0.00000481. So instead of writing out that long decimal, we're putting it into scientific notation. And you may notice the decimal actually just moved 6 to the left. So that's how it works if you're taking scientific notation and putting it into standard form. So these examples suggest the following rule for expressing a number written in scientific notation in standard notation, and the rule is going to be right here. This is something worth writing down. Going from scientific notation to standard notation. Okay. Use these steps to express a number in standard notation. So determine whether n is greater than 0 or n is less than 0. Okay? If n is greater than 0, meaning it's 1, 2, 3, if it's a positive number greater than 0, it'll be a positive number. Move the decimal to the right. So I'm going to write it like this. Well, if n is greater than 0, so positive exponent, move decimal point to the right that many places. If n is less than 0, or it's a negative exponent, we're going to move the decimal to the left that many places. You can add zeros, especially if you're moving the decimal to the left. You'll have to add zeros in there, and a decimal place, or a comma if you're dealing with a large number. So let's just do a couple examples. Here's the first one. Express this number in standard form. Well, we've got 2.45 times 10 to the 8th, so it's a positive exponent. So we're going to take 2.45, and we're going to move it 8 places to the right. 1, 2, 3, 4, 5, 6, 7, 8. And we're going to add in zeros. And that number is actually, we'll put commas in there too, 245 million. So that's what we have right here. So instead of writing it as 245 million, we can write it as 2.45, because that's between 1 and 10, times 10 to the 8th power. Second example, we have a negative exponent. So we have 3. If there's no exponent, we put it after it. It's 3.0. But if it's a negative exponent, now we move it to the left. So I'm going to go 1, 2, 3, 4, 5 to the left, and that's where our new decimal point is. Fill in the zeros. Whoops. Not sure how that happened there. And our answer would be 0.00003. I believe that's what we have here. So we moved it 5 to the left because there's a negative exponent. Think of a number line. Negatives are left, positives are right. So that's how it works for these. I'm going to have you pick 2 of these 2 right here. Pause the video and try 2 of those. I'll show you the answers in just a second. Alright, so you can look at each of them. Number 4, since it was a negative exponent for the power of 10, I would take the 2 and put the decimal after it, and then move the decimal 8 to the left. So I end up getting 0.00000002. Number 5, it's a positive power of 10, so I move it 3 places to the right, so I end up just getting 4,590. Number 6, it's a positive 14 power of 10, so I move that decimal 14 places to the right, and I get 718 trillion 300 billion. And then number 7, it's a negative exponent, so I'm going to move the decimal 5 places to the left. You get 0.000036. So that's taking a number in scientific notation and writing it in the normal standard form, standard notation of writing a number. Now, part of this goal is also to write the opposite, do it the opposite way. And this way is backwards. And I want you to think of it as backwards. So here's the steps that would be worth writing down. You don't have to necessarily write everything, but going from standard notation, like an actual number, big number, or really small decimal, to scientific notation. So it says move the decimal point so that it is to the right of the first non-zero digit. That will be the A. That'll be the first part. Number 2 said observe the number of places and the direction in which you move the decimal places. And then finally, if the decimal place moved to the left, it's going to be a positive exponent. And if it moved to the right, it's going to be a negative exponent for the power of 10. That's backwards from what we did before because we are going the opposite. So it's the opposite of what we did before. Meaning since we're going now from standard to scientific, we do the opposite. So here is your first example. We have 30,500,000. So I'm going to take that 30,500,000 and you have to move that decimal. It would be here. We have to move it back till it gets 2, 3, 4, 5, 6, 7. Till it's before that, or right after that first non-zero digit, which would be 3. You have to have a digit in front. So it would be 3.05, and we moved it, let's see, 1, 2, 3, 4, 5, 6, 7 to the left. So it's going to be a positive exponent of 7. So that's where this would be your new scientific notation. And to double check that, you can say it's 3.05 times 10 to the 7th. So I move that 7 places to the right, and hopefully you get back to that number you started with. Okay? Just follow those steps. Here we have a decimal that's very small. So I'll have to move it the other direction. So we're going to move this decimal 1, 2, 3, 4 places. So there would be 7.81. We're going to make it multiply it times 10 to, since we move it to the right, we do the opposite. So it's going to be a negative 1, 2, 3, 4, I believe. So let's double check that to see if that's what I have here. Yep, we moved it 4 places to the right, so it's going to be 7.81. That's a number that's between 1 and 10. And then it's times 10 to the negative 4th power. So why don't you pick 2 of these again, try them on your own, pause it for right now, and then I'll show you the answers in just a second. Alright, I want to write down one thing here. It might be worth putting in a box off to the side in your notes. I just put this box right here. So as a reminder, if you're having a really big number, really large number, that's a terrible little arrow there, so I'm going to blot it out and go like this. If you have a really big number, it's going to be a positive exponent for the scientific notation. Remember, you always have to have that times 10 to the power. If it's a very small number, like we had in example B there, where it's a decimal like that, it's going to be a negative exponent. So that's another way to remember when you're going this way. So I have the answers right here. Number 8 is a very big number. It's a 56 million something, so it is a positive exponent. And to get to that so it's a number between 1 and 10, it would have to be 5.67. And then that would be moving it 7 places to get it there. So it's 5.67 times 10 to the 7th. Remember, that first number always has to be between 1 and 10. Second one is also going to be 5.67. To get it there, we'd have to move it 3 places. And since it's a tiny number, it's a negative exponent. Number 10, very tiny number as well. So I need to change this. I made a mistake. This should be a negative 11. Okay? Because it's a very small number. And 4, you have to move it all the way so that the decimal would be right here. So that you have 4 is a number between 1 and 10. And that would be times 10 to the negative 11th. And then looking at number 11, we have to get the 3 and the 2 in there. So it'd have to be 3.002. It's a number between 1 and 10. And then times 10 to the positive 15th power. 15th power to get it all the way to that place. All right? So that's going from scientific notation, or that's going from standard notation to scientific notation. Now I have one last real-life example for you that we can look at. And, well, it's 2 of them technically, but I wanted to show you that you will often see large numbers in media or in science or in different places that, such as 3.2 million. They say 3.2 million, and that is kind of like partial scientific notation, because it'll be 3.2 times 10 to something. In this case, it'd be times 10 to 1, 2, 3, 4, 5, 6 power. And so that's just where that 3.2 million comes from. But here's an example of a real-life example here too. It says the graph shows chocolate and candy sales during a recent holiday season. And we want to write those are all written like that. Express the number of candies in standard notation and then also in scientific notation. So standard notation, 120 million. You'd have to write that as 120 million. 300 million would be the same thing, only 300 million. And then 1.45 billion, excuse me, that would be 1,450,000. Sorry, 450 million. Okay. So if it was a 145 million, that would be 145 would all be before that comma, but since it's 1.45, it would be 1,450,000 or 1,450,000,000. Now we can use those numbers We can write them into scientific notation. So for instance, 120 million, we'd have to do 1.2, sorry. 1.2 would be the number that's between 1 and 10. And to get it back, that it's going to be a big number, so it's going to be a positive exponent. Times 10 to the, and it'll be 1, 2, 3, 4, 5, 6, 7, 8 will be the exponent for that one. 300 million will be the similar. It'll be 3, and this is also going to be times 10 to the 8th. So it's the same number of digits there. And then the last one, we had 1.45, so it's going to be 1.45 billion. So it's going to be times 10 to the, I'm going to have to count. 1, 2, 3, 4, 5, 6, 7, 8, 9. So 1.45 times 10 to the ninth. And those are some real life examples of going from, um, well, writing numbers in different ways and putting them into scientific notation or backwards. All right, so if you have any questions about this, make sure you write them down and ask a teacher next time. But again, our goals were to express numbers in both scientific notation and standard form, so going back and forth. And next time we're going to do some operations, like multiplying two different numbers in scientific notation together. All right, have a great rest of your day.